Hi, Assalamualaikum. My name is ATHIRAH binti AZMI from CS 1435D. Introduction to radioactive decay. Radioactive decay is a random process in which the energy of an unstable atomic nucleus is lost by radiation emitted. Radioactive atoms will decay or disintegrate into atoms of another element or isotopes of the same element. The half-life of a radioactive substance, written as T1/2, is the time it takes for half of the initial substance to decay. The radioactive material is more stable if its half-life is longer. For example, radioactive radium-226 has a half-life of roughly 1,600 years, while uranium-238 has a half-life of about 4.5 billion years. The population model and the mathematical model for radioactive decay are the same. Problem statement. A group of archaeologists from Company A have conducted a study on 900 grams of carbon-14 to determine the lifespan of the radioactive isotope. After 4.5 years, it is found out that the remaining amount is 560 grams. First question. Find an expression that gives the amount of the isotope at any time t. Second, determine the half-life of the radioactive isotope. And lastly, how long does it take for this isotope to decay 70% of its initial mass? Objective A. To educate individuals on the subject of radioactive decay. B. To be able to find an expression that gives the amount of the radioactive isotope at any time given. C. To be able to calculate the radioactive isotope's half-life.
Now, let's move with the formulation of model and method of solution. The first step is separate the information from the question into short form, which is M refer to mass of the isotope and T for time. Second step is applying the general formula of radioactive decay with K as a constant. So, the formula is dm/dt equal to k dt. Third step is separate the equation where one side is dependent on m while the other side is dependent on t. After separate, the formula will be simplified as 1/m dm equal to k dt. Next step is integrate both sides of equation. First is integral of 1/m dm equal to negative integral of k dt. After we integrate, the equation will be exponent ln m equal to exponent negative kt plus d. Next, m equal to exponent negative kt multiply with exponent d. So the result will be m equal to c exponent negative kt. Just let c equal to exponent d. Since the half-life of a radioactive affects the stability substance of a radioactive, we need to understand that the longer the half-life, the more stable the radioactive substance is. Therefore, the simplified formula for computing half-life should be T half equal to -1/k ln 0.5.
These are the solutions for the problem statements. Firstly, we want to find an expression that gives the amount of the isotope at any time t. We let Mt be the mass of the isotope at time t. It is given that when the mass is 900 grams, the time is 0, and after 4.5 years, the remaining mass is 560 grams. Then, we apply the conditions given in the equation Mt equal to Ce power negative kt. Next, we substitute the first condition into the equation. So, M 0 equal to 900 and CE negative K0 equal to 900. After that, we get the value C is 900. After we get the value C, we can find the value of K. We substitute the second condition when T is 4.5, M is 560 into the equation M equals to 900 E power of negative KT. And we get 900 E power negative 4.5 K equals to 560. Then we will get E negative 4.5 K equals to 28 over 45. We put ln on both sides and we get negative 4.5 K equals to ln 28 over 45. At the end, we can solve for the value of K. So, we will get K equals to 0.105435. Thus, the amount of isotope at any time T is MT equals to 900 E power negative 0.105435 T. The second problem is we want to determine the half-life of the radioactive isotope. The half-life of the isotope is the time when the amount left is half from the initial, equals to 450 grams. Therefore, MT equals to 450. Then we substitute the equation from A to get the value of T. After we substitute all the values, we will get the value of T equals to 7 years. And then we can make the conclusion is the half-life of the isotope is approximately 7 years.
Assalamualaikum warahmatullahi wabarakatuh. My name is SYARIFAH NURALISA binti Said HUSSAIN. Next, I will continue the presentation about the results of solution for question C. In this question, it was asked how long does it take for this isotope to decay 70% of its initial mass. First of all, to solve this problem, we have to know the C first and also its half-life for carbon-14. Based on question A and question B, we found that C is equals to 900 and its half-life is approximately 7 years. Now, let's look at question C. First of all, we need to apply the initial condition M7 equals to half 900 equals to 450 into equation MT equals to CE the power of negative KT. After we apply the condition into equation, we will get 900 E the power of negative K7 equals to 450. Now, solve the equation. Divide 450 by 900 and we will get 0.5. So, E the power of negative 7K equals to 0.5. Next, we need to apply ln for both sides so that we can solve the exponential in the equation. So, we get negative 7K equals to ln 0.5. Divide ln 0.5 with negative 7 and we will get K equals to 0.099021. So, the remaining mass of the isotope at time T is MT equals to 900 E the power of negative 0.099021 T. Next, find the decay mass of 70% of its initial mass by multiplying 70% with 900 and we'll get 630 gram. It means that 630 gram isotope has decayed from 900 gram before. But to find how long does it take, we need to find the remaining mass of isotope after decay first. Minus 900 and 630 and we'll get the remaining mass is 270. Now, the equation for remaining mass that we find before, we equal it with the remaining mass of isotope after decay which is 270. Next, solve the equation by using the same method as we want to find the equation for remaining mass before, but this time we have to find T. So we'll get T is equals to 12.1587 and approximately 12 years. So the final answer is it takes about 12 years for this isotope to decay 70% of its initial mass.
Assalamualaikum warahmatullahi wabarakatuh. My name is SITI binti Muhammad SIDIK. I would like to present about our discussion in case study. Okay, for the first question, we separate the information into MT, which is the remaining quantity of certain radioactive substance at time T, and apply the general formula of radioactive decay. Hence, we can find the expression for given amount of isotope at any time T, which is MT, equal to 900 e the power of negative 0.105435 T. Okay, for the next question is, we can determine the half-life of the radioactive isotope using the simplified formula from computing half-life, which is the half amount left from 900. From the solution, we can conclude that the half-life of the isotope is approximately 7 years. Lastly, we are able to find how long does it take for this isotope to decay. By applying the initial condition given, we can find the value of C and K, and using the particular solution to describe the remaining mass of radioactive substance at any time. For our calculation, this isotope takes about 12 years to decay 70% of its initial mass. From this case study, we can conclude that radioactive decay can be used for solving our problem in our daily life. We know that radioactive isotope has been used in many applications in our daily life, such as in medicines, research, and so on. For example, we can solve the problems that faced by a group of archaeologists, which is conduct a study about carbon-14, which is to determine the lifespan of radioactive isotope.